Hi everyone. This is a very quick video that I am trying to create for those people who want to understand TLS. This is this is one of the important topic which needs to be understood when you are trying to attend some of the system design interview questions. Uh, I will be concentrating TLS 1.2 protocol here. I won't concentrate on TLS 1.1 or 1.0. I should have concentrated on TLS 1.3, but I will concentrate on TLS 1.2 first and then go to TLS 1.3. Saying that, I have quickly drawn some of the steps that are necessary. You won't see the full RFC documentation here. My main goal is to explain to someone who understands TLS protocol very easily, right? Like who needs to understand the protocol very easily. So saying that, what I have done is I have drawn a web browser and I have drawn a web server here. And the first step when we try to make a connection between a web browser and then the web server is they try to make the exchange of the cipher suits. So the web browser will say, these are all the cipher suits that I am aware of, sends that information. The web server will send the information to the web browser saying that I have selected the cipher suit. And once that cipher suit exchange happens, then the web server will send the certificate to the web browser saying that, hey, this is the certificate that you are trying to make a connection. The web browser verifies whether it's a valid certificate or not. Once it verifies whether the valid certificate or not, that is the verification, then what happens is the exchange of the key for the data encryption happens. The key exchange can happen in two ways. One is the web browser can encrypt can generate a symmetric key and encrypt that symmetric key by using the public key of the web browser and send the encrypted blob to the web server, and then the web server can decrypt it. That's one way. Or they can use a Diffie-Hellman key exchange, and by Diffie-Hellman key exchange they will secretly share a key across a web browser and then the web server, and through that secret key they can communicate to each other, and all the encrypted data flows from web browser to web server. This is a very far view uh, of the TLS 1.2 protocol. Now let's see everything in action. So for me, the one important question that comes to our mind is like, once the web certificate is sent from the web server to the web browser, what and all verification it does. So there are some websites which are available where you can put your IP address or the address that you are trying to communicate and then check for the SSL connection. So what and all it does is like it simulates. It is trying to see whether it results to this IP address. This is the server type. The certificate was issued by Let's Encrypt. Okay, the certificate will expire in 76 days. If the certificate date is less than if it is like if it has already expired, you won't be able to make a connection. It will throw, like it will give into mark here, and then it is giving you all the certificate and then the chain of the certificate. So this is the server certificate, bad SSL, and then this is the certificate. This certificate has been issued by this intermediate certificate, and this intermediate certificate has been signed by the root CA certificate. This is the verification which actually happens on the browser side. Now let's try to understand what happens via the Wireshark. Okay, let me open a Wireshark very quickly. So I have opened the Wireshark, and I will select the interfaces that I want to use for. I will be selecting my Wi-Fi interface, and I'll stop my connection at this point of time. And then I know the IP address of my the address that I am trying to use. I'll just put that IP address here and then start the connection. So at this point of time, it is trying to make a connection to that, but it is trying to make a connection, but I'm seeing different thing, but I'm not seeing the connection which is happening to 100.54 154.89.109, which is the IP address of the address that I'm using. So I'll just put the web browser address here and then try to do refresh. Now we'll quickly see the TLS was able to make this much connection. let me pause this, like this many number of packet it has sent. Now let us pause this thing and try to understand what and all connection, what and all packet has moved from the client to the server. First of all, let's try to understand from the client hello message. So my machine, my laptop's IP address is 10.0.0.36 and it has sent to 104.54.89.105, which is the IP address of this machine. This is the server. So it has made a connection to 104.54. The first connection is client hello. Let's click on client hello. And if you see here, Ethernet, IP, transmission, and then the TLS. So I'm more interested on TLS. So TLS version 1.2 record protocol. The client sends an hello message. In the client hello message, what it is trying to send is I'm not interested in the other field at this point of time. It will send the set of cipher sheets. So it has sent almost 19 cipher sheets to the server. That is what my diagram also says. So if you see here, negotiate the cipher sheets. So that's what I'm trying to explain to you guys here. So it has sent that message. Now the client has sent that message. Now it will come to the server. The server will, now let's go to the server thing. The server will send a server hello message. In the server hello message, out of 19 cipher sheets, it selected one of the cipher sheet and sent that message to the server. This is the handshake protocol, what it is trying to do. So the client sent an hello, the server sent an hello message, and once the server sends an hello message, it selected the cipher suite. Along with that cipher suite, what this TLS 1.2 along with that hello message, it has sent the certificates also. If you see here, it has sent three certificates. One is star.badssl.com, R3, and ISRG. So this is the one what we looked for here, right? If you look into the website, the SSL checker, what we just now checked, this were the star bad SSL, R3, and ISRG root X certificate. So bad SSL, R3, ISRG. This is the root sign certificate, and also we can also look the certificate from here. If you see here, bad SSL, R3, and ISRG. That is what the server has sent that message to the client. So the client hello is done, the server hello is done, and then the server certificate has been sent. Once the server certificate has been sent, then the server key exchange happens. So let's try to see the server key exchange message. So TLS record, the server key exchange, it is using a Diffie-Hellman key exchange protocol. And by using the Diffie-Hellman, it is sharing the secret key across the client and then the server. Once this key exchange is done, then the server will send server hello done message. Once the hello server hello done message is done, then what happens is, if you see here, there is the next packet is client key exchange. If I click on client key exchange, again there is a handshake protocol. It used the Diffie-Hellman key exchange, and then the change of cipher suite, it said that okay, this is the cipher suite that it needs to use, and the encrypted handshake message would be sent to the server. Now the server key exchange hello, server hello done, the client key exchange, change of cipher suite, encrypted handshake message is done. Then what happens is all the application data would be encrypted from the server to the client. And the application data protocol that it is using is HTTP over TLS. Okay. So this is how you, what happens at the back end. So this needs to be understood, and a very basic concept that needs to be understood when you are trying to attend any of the system design interviews. Saying that, I will end this session.